Hello everyone, and welcome to the Business Analysis Conference 2020. I'm very excited to be talking to you today, and my subject will be how we can use machine learning to make business decisions smarter, particularly automated business decisions. I'll be showing you how to use the decision model and notation, DMN, to integrate machine learning into your automated business processes. Please defer your questions until the end of the session. There's a chat box provided in the interface. When we come towards the end, there'll be 10 or so minutes for you to pose your questions and for me to answer them. Just a word of introduction. My name is Jan Purchase. I run a company called Lux Magi, which specializes in mentoring and training companies to use business decision modeling and also machine learning, and how to use them in tandem, very much what we'll be discussing today. And my colleague, Howard Rogers, is the product director of RapidGen, and RapidGen specializes in making very high performance decision execution environments. So my presentation today is really about three core assertions. Every business analyst, in my view, should be capable of modeling business decisions. It is that critical. Many analysts already know how to model business processes, but modeling business decisions is very much a lost art. And it's my assertion that every business analyst should know how to do this. Furthermore, machine learning is an essential part of, or increasingly essential part of business decisions, because it helps decisions to adapt and it helps them to be smarter. But this is a two-way relationship. Business decision modeling also helps mitigate some of the many risks there are when you come to use machine learning in your projects. And we'll be covering that in this presentation as well. Let's start with some basics. So why should business analysts be modeling business decisions? What's the benefit to them? What's the benefit to the company that employs them? Well, first things first, what is a decision? A decision is an operational piece of business logic, often automated, often run by companies hundreds, thousands, even tens of thousands of times a day. Things like determining the next best action for a customer, for example, trying to calculate someone's credit limit on their credit card, or working out what an insurance premium should be. These are all operational decisions which occur automatically and affect a company's relationship with their customers. And essentially, what's important about a decision is not necessarily the technical details of how it's achieved, but what the decision actually is. What is the logic underpinning the decision from a company's point of view? A decision always answers a single question. So in the case of next best action, there is one single question to be determined, and there is one answer to that question. And that answer may be one of a prescribed number of values, like, for example, denying or allowing someone a credit facility, or it could be some continuous value, like the upper limit of that credit facility, or the premium that has to be charged for an insurance policy. It can also be a collection of things, like a collection of products we want to recommend to a customer, but it's always one conceptual entity being returned. Decisions are repeatable. That is to say, if we invoke a decision twice with exactly the same circumstances, we would expect the same result to occur. And it's important to understand that business decisions are not processes. There's a very distinct difference between the two. Processes are typically about sequential series of activities, a sequence of actions or an interactions between two parties. Whereas a decision, on the other hand, is pure logic. It's purely an expression of how companies make their decisions. But there is an interaction between the two. In fact, decisions often steer business processes. The input to gateways in many business processes is often informed by a business decision. And what I'm suggesting is that decision needs to be modeled separately outside a process using a different notation. And I'll be discussing that in a moment. And it's important to note as well that although decisions are normally automated, it's possible to model decisions that are made by human beings as well. And it's very valuable to do so, in fact. So what does decision modeling do for us? Well, first and foremost, it makes every single business decision that a company makes a known entity. It makes it explicit and therefore on the agenda, if you will. And because business modeling helps to bring these decisions, some of them sometimes a bit implicit, into the light, and helps to communicate them between business analysts and subject matter experts, it means that attention is drawn to these decisions and they can be improved, they can be made more accurate, they can be made more reflective of what the company is trying to achieve, and they can be tested. Decision modeling makes decisions transparent. It enables us to see exactly what's going on and explain the behavior of the decision under all circumstances. It's especially formulated to be unambiguous. So unlike some representations of business logic, spreadsheets, Word documents, which can be ambiguous, business decision models are not ambiguous. In fact, so much so that they're executable. You can model a business decision, and I'll show you how in a moment, and you can actually deploy it into an execution engine and watch it execute. So business decision modeling is about making your decisions explicit, known, accurate, and ultimately executable. Decision modeling also helps determine decision structure, how different parts of the decision rely on each other, how they're connected. It also tells us about the requirements of the decision, what data is required to make our decision, what constraints influence us, and what behavior does the decision actually exhibit. So why model them? What's the benefit in having subject matter experts and business analysts sitting down and modeling these decisions? Well, first of all, the act of modeling often reveals flaws in people's thinking or misunderstandings that occur between business analysts and subject matter experts. Some business decisions are extremely complex, and modeling them can help divide and conquer individual decisions to help to separate them into simpler decisions which are more likely to be modeled accurately. A decision model is both a specification of what the decision is and also a means of executing it, if you like, a solution that can be automated. And it helps us discover what the data needs of every single decision are, what the constraints are that bind how we can operate, and also, to some extent, it helps communicate what the value of making a decision is. What's the benefit to the business? How do they measure the degree of profit or to reduce risk or any other benefit that the decision can bring? So when should businesses model their decisions? What triggers the need to model a decision? Well, I would argue that modeling nearly all your decisions is beneficial, but it's most beneficial when one or more of the following three things is true. First of all, if a decision has a high intrinsic value, if it's going to make you a lot of money, if it's going to improve your relationship with a customer in some way, help you retain the customer, for example, if it's going to reduce risk, then it's beneficial to model it. If it's going to help you detect things like fraud or wastage, that's another reason to model it. A second consideration is scale. If you're making the decision once or twice a year, then perhaps modeling is not very important. But if it's being made thousands of times a day, and each of those operations is adding some incremental value to your company, then it's essential that you model it to make sure that it's performing in the very best way that it can. And this is the case when we have a high volume, but it also can be the case when the outcome of a decision, the value of it, decays rapidly in time. If you're involved in trading, for example, the outcome of a decision can be worthless in a few minutes in some circumstances. So it's very important that you model it so that you get an absolute way of giving a real-time response to the decision whenever possible. And decision modeling is also handy when you have to make a decision consistently across multiple channels. If you're dealing with customers through a web interface, through a mobile phone application, and a hotline on a telephone, it is better to model your decisions in a way that means that all three of those platforms are going to behave consistently. And the last rationale is transparency. In some situations, you absolutely need decision-making to be transparent. It could be that it's extremely complex, and therefore there are many questions about some outcomes. It could be that you're implementing a decision which is part of a compliance regulation, and therefore you need to prove to a third party exactly how your decision works. In both of those cases, decision modeling is a huge value. It can also be useful if your decision is changing very rapidly in time, if it's very volatile, because then some kind of version control is necessary and changes need to be articulated and understood amongst a large number of people. And decision modeling is a good way of achieving that. So what does decision modeling look like in practice? I'd like to present a short example now. It's a little bit contrived, but I hope it conveys to you the essence of the process of decision modeling. I want to consider, say, a student loan application. And we're in a room, a group of business analysts, some subject matter experts, maybe one or two managers, and we're trying to model the student loan decision. So we might start with a simple pair of decisions here, and they're represented, as you can see, by these yellow rectangles. And we're trying to determine the maintenance loan that's going to be made available to a student and the grant. And of course, the distinction here is that we expect the student to pay back the loan, but the grant is a gift. So these are our goals, and we're going to try and model the decision and try and emulate what might happen in this room between the business analysts and the subject matter experts. Okay, the first thing we may decide is, well, what are the inputs to our decisions? Where are we getting the information from that's going to help us make these business decisions? And of course, the simple answer is a lot of the time we're going to be looking at the input from a student case. And this is how we represent inbound information. This rounded rectangle here, this green rounded rectangle, represents the student input. And these arrows represent the dependency of these two decisions on the input from the student case. But then we realize, of course, this isn't just a matter. It could be that subject matter experts point out that these two things are not independent. The loan and the grant are not entirely independent things. We want to make a coordinated award to a student, which is both the loan and the grant together. And in fact, the extent of the grant may actually reduce the loan facility we can offer. They may also argue that we need information about the university and the course that the student's going on. So the next stage of our decision modeling might look like this. So here's the input of the university course, maybe its duration, what the subject is, and here we can see that our loan and our grant are informing the overall loan facility that we're going to offer the student. But then subject matter experts point out that an important prerequisite of both working the loan and the grant calculations is to know what the allowable range of a loan is. Not every student is eligible for a loan, and there are often caps which apply in certain cases. So we need to work out the permitted range of a loan before we're able to calculate the loan itself. And that can be done here, for example. We're using now, we've introduced some extra sub-decisions which help us to calculate the available range of a loan and the available range of a grant in each case. And this helps to galvanize the subject matter experts into thinking more about how these specific sub-decisions work. And they might start thinking, well, actually, there's not enough here. We also need to know what the student's household income is, because the higher their household income, the lower the grant and the loan that they'll be eligible for. So we might introduce the household income in our decision making at this point. And it's the value add here of knowing how these different sub-decisions relate to each other, which gives us a big boon when we model decisions. And then we might find that actually the grant range and as well as the loan range are affected by the course. So we might need to add some extra dependencies there to represent that fact. And then the subject matter experts tell us, well, a lot of these decisions, a lot of these, the different stages will be using the same calculations to see how government caps affect the loan and the grants that we can make. And these calculations need to be represented as what are known as business knowledge models. And they're represented like this. So here we have a standard way of calculating the award limits set by the government. And those award limits are used by two decisions, the capped loan decision and the household income decision, because there are some awards which restrict our recognition of household income. Also important to household income are the ways in which we recognize the relationships between people in a household and the extent to which people in a household are financially dependent on one another. So if a student lives with their parents, for example, that might affect the loan to which they're entitled. And so the process continues. But it's important to realize that decision modeling isn't just a pen and paper exercise. Although it is designed to be used by subject matter experts and business analysts on a whiteboard, it's important to realize that behind each and every one of these yellow rectangles is hard logic. So behind, for example, the household income decision, we might have a decision table that looks a bit like this. And this decision table shows us all of the inputs to this particular subdecision: the student's age, whether they have a partner or not, their relationship with the people they live with, whether they're estranged from their parents, and so forth. And it has an output, in this case, the formula used to calculate the student loan. And so what I hope this shows you is that decision models aren't just about representing the dependencies, but also the detailed logic. Detailed enough, in fact, as I mentioned, that they can be executed. The decision model and notation, which is which governs the shape and form of some of the images I've been showing you, is defined by the object, the OMG, and it's the same organization that is behind the business process model and notation. It's been designed by 6 major vendors, including IBM and Oracle, and it was first released in 2014. It's designed specifically for use by subject matter experts in conjunction with business analysts, and it's designed to be precise and unambiguous. So there's an absolute minimum of technical detail in a decision model, but there is still enough to execute it. It's widely supported. There are now over 20 different tools that can be used to capture business decision logic, to express the diagrams that we've seen, and also to make this an executable entity. If you want to know more information about the standard itself, here's the URL you can go to. So, as a business analyst, why should you learn the decision model and notation? Why should you learn DMN? Well, it's first and foremost a brilliant way of capturing business knowledge very concisely. It's just so much better than all of the alternatives. Typically, business analysts use spreadsheets. Some actually use pseudocode. Some use Word documents. This is much more precise, much more easy to maintain, and ultimately has many other advantages that we'll cover in a moment. A specific one is that it, as part of the decision making, it defines all of the objectives that the business has in making the decisions. How do we measure ultimately how effective a business is in terms of this decision? How do we then use that to continuously monitor the decision and make sure that it's delivering all the value it should? How do we recognize the needs and the issues and the opportunities that decisions have? And decision modeling allows you to capture all of these things and supports this real-time monitoring. It's also really good at getting subject matter experts engaged in the process. I've seen some of them really start to own these models. And that, as a business analyst, that's a tremendous boon. It also helps to facilitate the search for better ideas. So once you've captured how you think this business decision should be made, it's an excellent start to work out how you could improve it, how you could make it better, what flaws there may be in it. And it also helps to provide accountability, because each and every decision model is capable of explaining its outcome in a particular case. Want to know why it is that you rejected a particular customer, a line of credit? A decision model can tell you that. Want to know why a particular case was highlighted as possibly fraudulent? A decision model can explain its outcome. It can tell you that. It's also a great vehicle for supporting change management, because we can see the differences between one version of a decision and the next and be explicit about the reasons for those changes. And first and foremost, and most important for my presentation today, is it helps integrate machine learning. into your business decisions to make them smarter. So just an aside for those of you who may not be familiar with machine learning, what is it? Well, quite simply, it's a way that you can get a machine to learn from data. It's a way you can get an automated system to perform a task and get better at performing a task just through experience, just through looking at historical data. Essentially, it's a way of using existing data both to automate the present and in some cases to try and predict the future. And all of this without any explicit rules or programming. So how does machine learning help us in our decision-making journey? Well, some business policies are very difficult to sit down and articulate from scratch. There may be a huge amount of history involved, there may be a lot of data, and it's very difficult for human beings just to sit down and just imagine or somehow construct from raw cloth what the decision-making is. And they are best learned not by trying to mandate some overarching set of rules, but by using the data to learn what the optimum strategy is. This is often the case when rules would be too complex, too expensive to capture using SME and business analyst engagement. It could also be that there's some disagreement in the company about how a particular policy should work. And we're going to use machine learning to try and find out what the best policy is, given our experience to date. It's sometimes the case that humans just don't know the rules, and therefore we have to use the data and machine learning techniques in order to recover, to mine that information. And some processes, or some policies I should say, just change too quickly. So we need to use machine learning to make our decision-making adaptive, sometimes in real time, more often in longer time frames than that. But nevertheless, we need to make it change continuously, automatically, because manual change is just not feasible. We need what's called continuous adaptation. An example of this is market analysis or monitoring customer buying habits in real time. So what do learning decisions look like? What kind of decisions do businesses have that typically learn? Well, a common one is market segmentation, trying to model customer demand and working out what individual customers want from their past history. This is something many of you would have heard of, recommender systems essentially. A similar thing is next best action, next best offer, modeling individual customers at the personal level to find out what is best, what best offer you can make them. Dynamic pricing, that's a bit of a controversial one, how you can change the price of your product to maximize the chance of a sale and also profit. And of course, using unusual behavior, outlier behavior, in order to identify possible instances of fraudulent activity. An important one that's emerging in some financial industries is the concept of customer lifetime value, being able to predict how valuable a given individual is in terms of their lifetime potential purchases, and how you can use machine learning in order to try and predict this. And another one, of course, is anticipating churn, working out how likely it is that an individual will leave your company for the services of a rival in the near future. Because, of course, you want to anticipate that so you can do something about it. Another popular area for machine learning is sentiment analysis. And this is often used, for example, to automate the process of looking at customer product reviews to work out what the sentiment behind them is. It's a very manually intensive job, and having a process that can do it automatically with high accuracy is very valuable. Also, to save first-line support resources, very often machine learning, particularly text analysis, is used to triage inbound support requests so that we don't have to bother frontline support for the less important cases. So what does machine learning actually bring to decision making? Well, it allows us, it gives us a unique opportunity to combine these two things that I've been talking about. On the one hand, SME's knowledge and experience the way they can formulate rules, the way they can capture the dependencies and the inputs to all of their business decisions. And on the other hand, the statistical benefit that machine learning brings, the ability that machine learning has to look at your past data and to mine new rules from them automatically. And decision modeling gives you a framework to combine these two powerful resources and help them work in unison. Machine learning also has a lot of data exploration and visualization tools, which can be extremely useful when applied to business decisions. It's possible to visualize the decision boundary of your decision. For example, where you would and would not award a credit facility to someone, to a customer. And it's possible to see how that boundary coincides with the boundary of profitability, for example. And being able to visualize, being able to see a diagrammatic representation of your company policy is an excellent way of trying to improve it. And it's also the case that machine learning has a lot of metrics, a lot of ways of measuring performance, which can be applied to business decision making. I've mentioned a few here. I'm sure that many people here won't have heard of them, and it's not important what the specifics of these metrics are. It's just important to realize that machine learning metrics are very powerful, and they can be applied not necessarily purely to machine learning, but also to business decisions and the making of business decisions and monitoring their performance. So how might we use machine learning in our student learn example? Well, one possible example is to insert a decision here. This risk adjustment decision you can see is orange. It's actually a machine learning decision. So it's not just straightforward decision tables like these other decisions in yellow. It's actually using machine learning. And here we are using the career profiles, historic career profiles of individual students, along with details of the student course, to predict the level of risk associated with a student loan. And once we know the level of risk, we can then apply that to the loan facility, for example, the repayment schedule and the amounts. And because of that, we've now given our student loan decision some statistical benefits. We have allowed it to start learning about how historically students have paid back and how the subjects that they're studying affect and the terms over which they study affect their ability to pay back. I mentioned earlier that decision modeling also gives value to machine learning. How does that work? It's hopefully clear how you can use the benefits and power of machine learning in your decision making to make it more adaptable. But what does decision modeling bring to machine learning? Well, machine learning projects have three main reasons for failure, and modeling decisions can help mitigate all of them. One of these is that very often machine learning fails because companies are in a huge hurry to implement it. They see the artificial bandwagon, they want to jump on that bandwagon, they want to get running as soon as possible, and they overlook the strengths and weaknesses of machine learning, and they don't quite know what their goal is. They know that they want to use the technology, and believe me, the technology is very alluring, but they're not quite got a firm idea of what they're trying to achieve. And that's often the case. And there's a lack of business cohesion as well, a lack of integration with end-to-end business process for the machine learning. As you've already seen, modeling decisions gives us that anchor. It gives us a firm way of defining the KPIs and objectives. And consequently, it gives us a way of making sure that we have properly defined goals and that we are cohesive with our end-to-end business model. Very often in machine learning, there's a failure to follow process. People have unexpected results. They don't know what that means for the evolution of their machine learning model, and they start going off the process. Decision modeling helps here by providing a very strong process and an anchor again for developing and changing business-based machine learning models. It's also the case that machine learning models work really well when they're deployed. So there's a great launch a huge celebration. Everyone sees that the end of the project is at hand. But there is a misunderstanding that this is just the beginning. Machine learning models need to be continuously evolved. They need to be retrained on a regular basis because business environments change, customers change, the ways in which the markets behave continually change. And therefore, the launch is not the be all and end all. It's also monitoring, in-life monitoring of how these machine learning models are coping. And decision modeling gives us a framework to help with that as well. The one risk of machine learning projects which isn't really covered by business decision modeling is the fact that there are few people out there really understand deeply what machine learning is at the moment and what it isn't. And unfortunately, decision modeling can't really help with that. So how does decisions enrich machine learning? Well, they provide a context for machine learning. We've already seen from the student learn example that that single machine learning model had well-defined inputs, it had a well-defined output, and it already has a connection with the business process, because as you remember, a decision model integrates with your business process in a firm way. So the context is the definition of the inputs, the definition of the outputs, a clear statement of the goals for the overall decision and each sub-decision, key performance indicators which can be modeled continuously in real time. How well is this decision doing on a day-to-day basis? Is it achieving its goals? If not, which goals are not being achieved and why? And I mentioned process integration, a firm connection to the end-to-end business process. And it supports MLops. Those of you who know what DevOps is, it's a way of continually delivering value into business automation. Machine learning has an equivalent called MLops, and decision modeling can help with this. So decisions give machine learning a framework for better discontinuity control. So what I mean by discontinuity is, some of you may be aware that machine learning models sometimes, under rare circumstances, give bad results. They give surprisingly bad results in individual cases. And decisions can help detect that and prevent it being a problem. Decision models, as we've already seen, give us interpretability. They give us the ability to explain why a particular decision had the outcome that it did. And this is very important because a lot of machine learning models don't have this. They're famous for being very accurate and very powerful, but they don't explain their outcomes. They're inscrutable. It helps to manage drifts. So I talked earlier on about the business constantly changing. This means that sometimes over time, machine learning models go off the boil. They become slowly less effective and they need to be retrained. And business decision models can help us detect the moment where this retraining is required. It can help stop hackers from providing information that's deliberately aimed at derailing machine learning models. Some of you may be aware that image detection models can be foiled by wearing a simple fractal badge. You can get a traffic camera, for example, to recognize you as a traffic sign or as a building just by wearing these small badges, because there's adversarial data, there's specially designed data on the badge that when scanned optically, it confuses the machine learning model. Decision models can help detect and stop that adversarial data. And they can also provide a certain degree of ethical monitoring as well. It's important that machine learning model only has one job, and consequently, our decision model can help divide and conquer. It can help separate individual machine learning models into separate machine learning models which won't conflict or have any internal conflict. Let's have a look at some examples of that, because I appreciate those are a lot of new concepts for some of you. I want to try and illustrate them now by example. So let's take a decision model that has to calculate the value of a diamond given the image of the diamond in several different wavelengths of light. And this is a commonly accepted way of estimating diamond value. There are lots of different ways to do it. Many of them involve machine learning. And here, what we have is 4 different machine learning techniques, all of which can measure the value or predict the value of a diamond using an image in different qualities of light. And what this particular pattern is doing, it's called the ensemble, is it's bringing together these 4 different approaches and then voting. So it's getting a result from each one of these methods, and then it's voting. So if any one of these methods fails in an individual case, maybe there's a weakness or a flaw in these individual methods, and these are all real methods. This is the GIA, it's a US diamond authority. The AGS is the diamond certification authority. IGS, I think, is based in Washington, and the HCA is the Holloway cut advisor. They're all different ways of analyzing the values of diamonds, and we are using the wisdom of the crowd to bring them together, so that should any one of them fail to produce a good result, they'll be picked up by the others. So this is a way that we can manage discontinuity. This is a way we can improve the reliability of machine learning models by voting amongst many of them. Another approach, another use of combined machine learning and decision modeling is the use of what's called the monitor. So on the right-hand side here, we're trying to make a business decision about whether a client is likely to leave us or not for a competitor. So we're taking the event history of a particular client and all of the client details, and we're using a machine learning model here to calculate the likelihood that this client will leave us for a rival in the next 6 months. And if we find that there is an unacceptable likelihood of that, then this decision here assesses the need for preventative action. Maybe we make the special deal to the customer, or maybe we give them some cash back or some other incentive to stay with us for another 6 months. On the left-hand side, we have a decision whose job it is to monitor how effective the decision on the right-hand side is. And it does this by taking all the qualifying events, determining the accuracy of the decision, and then notifying the systems if it feels that the accuracy of the decision has gone below an acceptable level. If it has, then this churn propensity decision will need to be retrained. This pattern helps us to explain the outcome of inscrutable or what are called sometimes black box machine learning models. So this is a medical example. We've got some patient data here going into this machine learning model, which calculates an advanced diagnostics and makes predictions about certain prevailing medical conditions that the patient might have. But it's unable to justify its outcomes. It can give a list of possibilities and their probabilities, but it can't say why. So we have a decision here, a set of decisions supplied by a subject matter expert to help generate an explanation given the same patient data. So the right-hand side is doing the work of prediction. The left-hand side is helping us to explain that prediction. And then we get a combination that's genuinely useful to medical professionals because it provides an accurate indication and an explanation of that outcome. And in the last of our models, the cage, this is an example of a model which prevents discontinuity in machine learning models, prevents unusually bad answers in a few cases. This is a model that helps predict the value of a house. So at the bottom, we have inputs of the house details and the area details. That's being fed into a machine learning model that predicts the house's value. But although we're using this as the basis of our evaluation, we're also taking evaluations from external systems. Here, the Zoopla estimator and the Casal-Mansion estimator are both being used on the same house, and they're also generating potential values. And then we're comparing the three. And if we find that our prediction is significantly different from the other two, we may have to record that this particular model has made a mistake. And this indication may indicate the need for retraining. Sometimes not, it could be a one-off. Sometimes it might indicate that our model needs to be retrained. Okay, I hope you found that useful. I hope it's giving you an indication of the power of decision modeling and how it can be combined with machine learning to make your business decisions more intelligent and more adaptable. If you want to find out more, there's an excellent paper called the ML Test Score by Breck that talks about the practicalities of deploying machine learning in business. And also the excellent Machine Learning Yearning by Anu Ng, who is quite a luminary in the machine learning community. That's definitely worth a read for a very practical analysis of how you can use machine learning. And the book I co-wrote with James Taylor on real-world decision modeling also explains how you can use analytics and machine learning in tandem with decision modeling. I just want to leave you with a few parting shots before I go. It's important for a business analyst to be able to communicate effectively. It's important for you to really work with SMEs and grasp business logic and how it works. So, in my view, business analysts really need the decision model and notation for capturing business logic effectively and communicating it effectively, for integrating machine learning into your business decision making, and for ensuring that these models are able to explain themselves adequately, ensure that they're able to bring some light as to how some of these machine learning models are being used, and also for addressing the many risks that machine learning deployment can bring to a project, as well as the benefits. Okay, that's pretty much all we have time for. So I'm now going to go over to the chat and invite questions from the audience, and I'll be answering them as soon as we see them. So do please feel free to type in your questions. You can refer to individual slide numbers if you want, and I'm now going to answer those questions. Thank you very much indeed for your attention today. I hope you enjoy the rest of the conference.